Welcome to our explainer. You ever stop and think about all the plastic things around you? How a simple handful of tiny plastic pellets becomes the complex, super durable objects that pretty much shape our entire world? Well, today, we're pulling back the curtain of the hidden force behind, well, everything from your phone case to your car's dashboard.
I mean it. Just take a look around you right now. Your keyboard, that food container, a kid's toy. Our lives are literally built with plastic. And it all starts as these simple little pellets that get their shape from one seriously powerful machine.
You know, the transformation from those little pellets into a complex part, it almost feels like magic, doesn't it? So, how does it really happen? How do you go from a pile of raw material to a finished product with such mind-blowing precision? Okay, let's dive right in. Here's how we're going to break it down. We'll start with the machine itself. Then we'll get into its powerful liquid heart. After that, we'll see how all that force is controlled. And finally, we'll put it all together to see how the whole system works. All right, so the answer to our big question lies inside a true marvel of engineering, the injection molding machine. You can basically think of it as a super hot furnace and a massively powerful press, all rolled into one highly precise package. The whole process is this really cool, repeatable dance. The machine feeds in pellets, melts them, clamps a mold shut, injects the plastic, lets it cool, and then pops out the part. But the real secret, the absolute key to success, is step 3, clamping. This is where the machine has to unleash just a staggering amount of force to hold that mold shut. And that brings us to the core challenge, right? How in the world do you generate and control a force that's equal to, say, a whole stack of cars, and do it with pinpoint accuracy over and over, thousands of times a day? The solution is incredibly elegant and powerful, fluid power. So to really get how this is even possible, we need to look at the machine's circulatory system. This is where the real muscle comes from, by harnessing the unbelievable power of liquids under pressure. See, at the core of most of these machines is a hydraulic system, and you can totally think of it as the machine's blood and muscles. It works by using oil, which is great because you can't really compress it. So when you push on it in one spot, that force gets transmitted to another spot, and you can multiply it into something enormous. So you might be thinking, okay, but why hydraulics? Well, honestly, they are perfect for this job. You get massive force out of a pretty compact system, the motion is super smooth, and get this, you can stall the system under a full load and it causes absolutely no damage. Plus, they have safety features like relief valves built right in. But, like any superhero, this powerful system has a weakness. Its lifeblood, the hydraulic oil. Even the tiniest little speck of dirt can completely destroy the machine's precision components. And that's why there's a whole network of filters and strainers working nonstop, just to keep that oil perfectly clean. Now, all that power starts with the hydraulic pump. It's the heart of the system. But here's something that most people get wrong. You'd think a pump's job is to create pressure, right? Well, nope. Its real job is to create flow. The pressure only shows up when that flowing oil runs into some resistance, like, say, trying to push a giant mold shut. And, you know, just like cars have different engines, these machines use different kinds of pumps. You've got your basic gear pumps, more advanced Vane pumps, or even piston pumps. The really fancy ones are super smart. They can actually adjust their flow on the fly, delivering exactly the right amount of power at exactly the right time. And this table, wow, this really puts the raw power we're talking about into perspective. Take a look at that 425-ton machine. It can pump 130 gallons of oil every single minute from a 250-gallon tank. To give you an idea, that's like emptying a massive bathtub in about 20 seconds. It's just wild. So okay, we've got all this raw power, this insane flow of oil just waiting to be used. But power without control is just chaos, right? How do you tell that force where to go, when to push, and exactly how hard? Well, the answer is a whole network of these little geniuses called hydraulic valves. Seriously, if the pump is the heart and the oil is the blood, then the valves are absolutely the brain and the nervous system, directing all that power with incredible speed and precision. So, these brains basically have 3 main jobs. Directional valves are like traffic cops, telling the oil whether to close the clamp or open it up. Then you've got pressure control valves, which are like the bouncers at a club. They set the limits and make sure things don't get out of hand. And finally, flow control valves. That's your gas pedal, controlling how fast everything moves.
All right, let's put it all together now. Let's see how these pumps and valves actually team up in a real-world circuit to solve a really important problem. Okay, so here's the puzzle. You need to close this massive, heavy mold really, really fast, because, time is money. But then, the second it's closed, you need an absolutely insane amount of force to hold it shut. It's that classic engineering problem, speed versus power. And the solution is it's brilliant. It's called a high-low circuit. Check this out. First, two pumps, a big one for high volume and a small one for high pressure, work together to slam that mold shut fast. Then, just as it closes and pressure starts to build, a smart little valve tells the big gas-guzzling pump to take a break. This saves a ton of energy. And finally, that small high-pressure pump works alone to apply that final crushing, clamping force. It's the best of both worlds. You get speed and power, efficiently. So clever. Now, hydraulics are definitely the heavy lifters here, but they often have a little sidekick, pneumatics. Instead of oil, pneumatics use compressed air. Now, it can't pack the same punch as hydraulics, not even close, but it's super fast and snappy, which is perfect for quicker, lighter jobs, like popping the finished part out of the mold. All this power, it demands constant attention and maintenance. And this number is a pretty stark reminder of that. 350 gallons. That's how much oil you can waste in a single year from a tiny leak of just 1 drop per second. It sounds like nothing, right? But it just goes to show you the immense, relentless pressure these systems are operating under 24/7. And at the end of the day, all of this incredible technology, the pumps, the valves, the circuits, it's all focused on one thing, the mold itself. And I love this quote because it hits the nail on the head. It's easy to fix a drawing, but fixing a multi-ton block of hardened steel, that's a whole different story. It can become a very, very expensive monument to a bad design. So the next time you pick up a remote control or see a Lego brick, or really any plastic object, just take a second to look at it. Because now you know the hidden story. It's not just a piece of plastic. It's the result of this incredible, invisible dance of immense fluid power and precision engineering that brought it into being in a matter of seconds. So now that you know, what everyday objects will you look at differently?